Good evening, all.
Good evening, sir. Good
How are you?
evening.
Good evening. How are you all? Fine. Okay. So today we will enter into another dimension of data analysis. So I just want to know, is there any doubt till now, whatever we have covered? Do we have any doubt? Anybody? Okay. So we have what we have covered till now. Please see. I'm just sharing my PPT. Okay. Once it is visible, please let me know. What all we have covered till now? Just we should list it down. We have covered the basic terms of research, then parametric and non-parametric. Then hypothesis testing means parametric, non-parametric comes under hypothesis testing. Parametric, non-parametric. Then we discussed about mm, um, EFA, exploratory factor analysis, regression, and reflective and formative scale. Then we went to CFA, SAM, mediation, moderation. So this we have covered till now. During the process, we covered the types of data. Types of data generally when we talk about, we talk primary and secondary. One more classification was also there, like data maybe your cross-sectional, time series, and family. So you can ask any problem if you have in these topics. If you have any kind of problem, you can ask. No problem. Just please tell me.
Hello, sir.
Yes.
Yeah, sir, I'm not sure if this is related to from these topics. I just wanted if it be, can you guide on how to formulate the questionnaire?
Um, okay. Can you specify your objective?
Hello.
Am I audible? Am I audible?
It is, sir, I'm studying the impact of spirituality on consumer buying behavior.
Okay. Spirituality on consumer buying behavior.
With is means it's special reference to FMCG products only.
Okay. Okay. So what are your variables here? If I talk, what are your variables? If I write your objective here, impact of spirituality
On
on
consumer buying.
buying behavior, if I'm not wrong.
Consumer. Yeah, consumer buying.
Okay. So what are the variables? From objective, you must find out your variables. So there are two objectives. One is spirituality. Second one is buying behavior. Okay.
Hmm.
So you have to measure your variables. Means you need to collect the data. So have you found any established scale for spirituality and buying behavior, or you will develop on your own?
For spirituality, there exists one scale,
Okay.
but not for spirituality and buying behavior both.
No, I'm asking, is there any established scale for spirituality and
Yeah, it is
it is
core spirit scale
separately
available.
also, separately also, if it is available,
Hmm. It is
then
available. Core spirit is the names of scale.
okay. So you see the statement of those scales. If
Okay.
they suits to you, you can take them and you can give the references. If you want to modify, then you can change the statements. You can add, you can drop, or you can modify the statements, and then you can collect the data on a scale because these both are, you know, unobserved variables. Spirituality and buying behavior both are unobserved variables. So you can observe them with the help of certain statements, observed statements. Okay, directly you cannot ask anybody, are you spiritual or not? Or buying behavior also you cannot directly measure. For that purpose, you need to frame certain statements on the basis of you will determine spirituality and buying behavior. Now, any specific question you have?
So can we do this on Likert scale?
Definitely you can. Actually, 5 point, 7 point, and Likert scale, you know what is the difference? I have discussed in previous sessions also. Individual statements is known as 5 point, 7 point, whatever is the point scale. But when we have more than one statement and if they have something in common means if both or more than two statements, if they are measuring the same thing, then it is known as Likert scale.
Okay.
Cumulatively, it is known as Likert scale. So all the statement of spirituality will be known as Likert scale.
Got it, sir. Thank you so much.
You're welcome. Any other question? Anybody else who has any question? So somebody is asking, mm, Sir, you can go to the website of Professor. You can go to the website of IBM. You can either purchase the software or you can download the free or trial version. So this is the only way. Okay. Anybody else? Anybody who wants to discuss his or his research problem, they are also welcome. Professor, you can download the trial version for some time for practice. It will be helpful for you. Or you can visit any library which has uh, certain, subscription of these softwares.
Sir, what is the difference between a Likert scale and a semantic scale?
So, Likert, as I told you, if we measure something on reflective scale, okay, reflective scale means I'm asking the same thing again and again, again and again. Then this will become Likert scale. Is it clear?
Yes, sir.
Means are you clear about Likert scale?
Yes, sir.
Then tell me next problem.
So, what is semantic scale? As far as I know, one is a 5 point scale and
Uh,
another is a 7 point scale. So, can you give us some example, like how to form a Likert scale and another for semantic scale?
Sir, actually, I'm emphasizing on the Likert scale again and again. The point is different. Different thing means Likert scale may be 5 point, Likert scale may be 7 point, Likert scale may be 9 point, Likert scale may be 11 point. So, but semantic scale is a differential scale. Sometimes the formative scale may also be known as semantic scale. In formative scale, we do not measure the same thing, but every statement measures the different things. So every statement works as variable, while in reflective scale, the statement does not work as a variable. A combination of certain statements work as uh, variable in the form of factor, or we call it factor, variable, or constant. Any other question? Any other question? Hello? Hello? Sir, did you get the answer?
Yes, sir.
Okay. So, okay. Let me see the chat box also. Sir, Prakhar sir, Prakhar sir, Prakhar sir, are you there? Can you unmute? Can you unmute? Okay. Prakhar sir, after this session, do you have my mobile number? I think you must be in the group. You must be in the group. Okay, you have my mobile number. Okay, so after the session, you please call me. After the session, you please call me. Okay, any other question? Any other problem? No. Now let's move ahead. So till now, what we have discussed about the cross-sectional data. Till now, like in SPSS amounts, whatever we were analyzing, that was cross-sectional data. So can anybody explain what is cross-sectional data? I have already explained to you what is cross-sectional data. Till now, we were discussing about cross-sectional data. There are three types of data on the basis of collection: cross-sectional, time series, and panel data. So in SPSS, in AMOS, in Smart PLS, we were talking about cross-sectional data. What is cross-sectional data? Anybody? No? Suman madam? Sritam sir? No idea about cross-sectional data? Shamta madam? Sapna Mishra madam? Yes,
Yes, sir.
yeah. What is cross-sectional data? I have
Uh,
discussed.
when we are collecting information on number of units, for example, we are talking about Sensex data. So there are number of shares which we are, the value which we are recording, and at one point of time.
Okay, very good. So the best example for cross-sectional data is census. Census data.
Yes,
Do you know census data?
yes,
I,
yes,
I have given the example of census data. Have you seen census data? Means, have you heard about census data? Census always we call about with reference to time point. Census
yes,
2001, census 2011. It means only one time point is there, and we have number of cross sections. What are the number of cross sections here? This is time point. What is time point? Time point, the year of census, and cross section. From where we collect the data? Households. So cross section is household, and time point is the year of census. So only one time point, and we have number of cross sections. Then this is known as cross sectional data. Till now, whatever we were discussing about analysis, we were discussing about cross sectional analysis. Now, today we will try to discuss about time series data. So what is time series data? Time point more than one, cross section one. Can you quote the example? Share price of RIL, let's say, for last 5 years. Clear? So what is cross section? RIL is cross section, and my 5 years is the time point, time period. So if I collect the data of one cross section over a time of time period, then this becomes a time series. If I combine cross section as well as time series, then it becomes panel data. It means more than one time point and more than one cross section also. So, madam, in your example, if you include the time point also, more time point also. So, Sensex is a combination of how many companies? Sensex is a combination of 30 companies. So, if I collect the data of 30 companies for 5 years, then this will become panel data. And if I collect the Sensex data for one single point of time. So, madam, can you tell me, Samta madam, can you tell me what can be the time point? What can be the time point in cross-sectional data with reference to Sensex?
When we are collecting data for various companies
Okay.
for say 5 years, it is Reliance, it is Wipro, it is Infosys.
Yes,
We take,
it will become panel data.
yeah, it will become panel data.
Cross-sectional data. I'm talking about what will be the time point in cross-sectional data. Cross-sectional data.
So
You have quoted the example in cross-sectional data, and example is 100% correct. But what will be the time point? Like in census, it is the year of census, 2011, 2001. But in Sensex, there are 30 companies, but what will be the time point?
share price,
Share price is the variable, but time point, what will be the time point?
time point could be time point means every day.
Time point will be only one. In cross section, only one time point is there. But what will be that time point? Okay. So either, yes, somebody, 5 year, sir, 5 year means this will become the panel data.
Panel data.
If I want to take the example of Sensex with reference to cross section.
If we take as on today, as on date,
Today, and during the day, the price of particular share has been changed many times. That's why I'm asking what will be the point, time point. During
so
the
maybe
day,
opening time
okay,
or closing time.
it may be opening, it may be closing, it may be low, it may be high. So any of them.
Yes, right.
That's why I'm asking again and again, either opening, closing, low or
Or
high. So always we work on share price data, and that is adjusted close. We always work on adjusted close. So we take adjusted close price. Okay. And what is the difference between close and adjusted close?
close and adjust.
Yes. Okay. Anybody,
No, I just
anybody who is working on a time series or panel data in our batch? Anybody who is working? Nobody is working on time series or panel data. Any student of finance, student means who is working on finance data, economics data. Nobody is working. Everybody is working cross-sectional data. Hello. Nobody is there. Okay. Prakhar, you are working, but you are in library, so you cannot discuss, I think. So if you are working on time series of panel data, so it is a means totally 1 week or 15 days activity for time series and panel data. Today I'm giving you some insight regarding time series and panel data. So okay, you are working on cross-section. So if in future you want to work on time series or panel data, or I want to create your interest to work on transient panel data also with your cross-sectional data. So today, what we will do, I welcome you all. Don't wait. Life goes faster than you think. So this year, 2022 will also pass. So you have to keep your pace with the trend. It is just beginning. So in the beginning, we have to learn things, then we will run. To enter the world of econometrics. Today we will enter the world of econometrics. So any idea about econometrics? What is econometrics? Anyway, please be interactive. Be interactive. So it is an interesting but quite challenging world. If it does not challenge you, it does not change you. So if you accept the challenge, you can change yourself also. Okay. So what we need
So
to learn?
application of statistics over the economic problems
Very good.
to solve the economic issues.
Very good. Very good, Chandra madam. So econometrics, let's see, putting the things in right place. So first some preliminaries we will discuss about. So what is the difference between business statistics, mathematics, quantitative techniques, or we can say operation research, and econometrics? So let's understand. You rightly said econometrics is econometrics deals with the application of statistical methods to economics. So whatever statistical methods we have, if we apply them on the economics, here economics means economic data, then we will say that this is the econometrics. Econometrics. So it provides unification of economic theories, mathematical tools, and statistical methodology. So unification means economics gives theories, mathematics gives us methods, statistical methodology also give something. So we must combine them, unification of them to understand econometrics. It is concerned with estimating economic relations. In econometrics, we try to establish the economic relationship between or among variables. Clear? Any doubt till now? Confirming theory with facts and hypothesis testing involving economic behavior. What we do? We confirm theory, economic theories with certain facts or hypothesis testing involving economic behavior of our variables or data. Next, forecasting the behavior of economic variables. Whatever are the economic variables, we try to forecast their behavior in future, how will they behave. So nature of econometrics, it is primarily empirical in nature, use the historical data and derive meaningful conclusion out of that. So on the basis of past data, we try to draw some meaningful conclusion for future. It is based on inductive logic, means on past data. It moves from specific to general. So theories are specific, and using econometrics, we try to generalize them. So from specific to generalized, general meaning, we use this. Let's see what. is the use of econometrics. Estimation, we estimate, we do hypothesis testing, and we forecast. So first of all, we will do estimation, we will test hypothesis, and we will forecast for future. What are the steps involved in developing econometric model? First, we will go to theory, underlying theory. Previous studies means review of literature we will do. Formulation of an estimatable theoretical model. We will frame certain estimatable model. Uh, so any model on which we will work based on the literature review. After that, we will collect the data. So in your case, madam, you have estimated model, but your model is based on cross-sectional data. So now decide variables, then collect the data. Then you will estimate the model. Is model statistically adequate? You will see the parameters, whether model is working or not. If model is not statistically adequate, then reformulate the model. If model is statistically adequate, then interpret the model and use for analysis. And again, this model will work as previous study for somebody else for the further studies. This is the procedure. So this is the model. Y is equal to alpha plus beta x plus error term. So is it clear? Y is dependent variable, alpha is constant, beta is slope, x is the independent variable, and error term is there. So model in econometrics is regression model. We frame regression model as we have studied earlier. What is regression? Regression analysis is concerned with the study of dependence of one variable, that is dependent variable, on one or more other variable known as explanatory variable, with a view to estimating and or predicting the population mean or average value of the former in terms of known or fixed value of data. So on the basis of known values of explanatory variable, we try to predict the population mean of dependent variable. This is regression model. Sometimes it is good to know about history. So some historical facts also we will discuss. What are those facts? Regression. Always we talk about regression. But what is the regression? Who have given this term? The term regression was introduced by Francis Galton, who found the tendency of child height to regress towards the average height in the population. So what is the child height? It will depend on the average height of the population. So he used to regress it. Regression analysis is concerned with the study of dependence of one variable, known as dependent variable, on one or more explanatory variable, with the purpose of estimating, predicting the average value of former in terms of known value of later. So who gave the term regression? This is Francis Galton. Now, it comes to deterministic versus stochastic model. So a model with the following function is called deterministic. Y is equal to alpha plus beta x. A stochastic model is represented by y is equal to alpha plus beta x plus error term. Can anybody tell me what is the difference between deterministic and stochastic model? Please, please come forward and discuss. Please discuss. This is simple regression equation. One is deterministic and one is stochastic. So what is the difference? Can you appreciate on the basis of equation? No one? Shanta madam?
Yes. Deterministic does not have error term, so it means um, the population data, like, or
Yes.
uh, where, where we are sure of the results.
Okay. Okay. And in
Here we are not leaving it of error, like, so what I assume
okay.
is this.
Okay. And in stochastic we have error terms.
Yes.
So having error term means
Then
So it
results
means
may,
that there may
yeah.
be some other factors also which can influence the relationship.
okay. Very good. Very good. So deterministic model means the model in which we are sure that X is the only factor which determines the value of Y. We are sure. Okay. So if we are determined about this, then this model will be known as deterministic model. When we are not sure that X will determine the value of Y and there is no other variable which determine the value of Y or which explains the variance in Y, then we add this error term. It means other things will remain same. It means whatever variance in Y is explained by X is not sufficient. Some other variables may be there. Okay, can we say some other variables are there, or should we say maybe there? Is there any difference in this language? If I say some other variables may be there which can explain some variance in Y, or other term is some variables are there which
In
may.
case of may, we are leaving to the probability, while in case of R, we are sure that there are other variables. So
Okay.
without studying the variables, I think we should go with the may word only.
Okay. Okay. Sapna madam, you want to say something?
Sir, it depends on the field of study, which subject we are dealing with. Especially if we talk about social sciences or psychology where
Okay.
human behavior is involved. Uh, I think most of the time we can have other factors also which can influence the relationship between two variables. But
Okay.
if we talk
Uh,
about sciences, maybe medical science or which are up to the mark, so they have a uh, confirmed relationship about two things.
uh, Sapna madam, one thing I want to know, either in medical sciences, is it necessary you will take this medicine, you will be fit and fine?
Definitely not, sir. It depends from person to person again, his
So
body
again,
systems and his
again in medical
acceptability of his
science,
body.
so again in medical sciences, there is always the scope for other factors.
Hmm.
Only the difference is
Error
confidence
terms
level is
involved there
high.
also.
Error term may be less, but always error term is there.
Okay.
Otherwise, there will be a list. If you have this kind of uh, illness or this kind of disease, take this medicine. No need to visit doctor.
Then what would be
Okay.
the example
So
for deterministic model?
for what? For what? For what?
For deterministic model, the relationship that we are studying in that.
If you study the complete population, then it may be possible.
Okay.
If you study the complete population, then it may be possible to define the deterministic model. But in statistics, what we do, we collect sample, analyze the data, and try to infer about the population.
Okay.
But I think even in collecting census, there are always chances of error. Like you may miss some of the data, or even in population, it is not 100% deterministic.
By the time they collect the data from one place, they go to other place, demographic changes by minor fraction.
Yes, yes.
So if you have that much
And
population,
sir, I'm not an economic student, but I know that in many of the economic definitions, there is the starting we do it from other things being constant.
yes, that's why we are talking about this error term. Always there is a provision for other things remain constant. Because we think that if other things will not change, this will be the impact. This is the assumption.
This will be the
Based on this, we frame. Okay, on the basis of sample, if we are analyzing, then this stochastic model will be there. Always there is a scope of error term. Error term. Okay, I was talking about maybe or if. If I say factors which there are other factors which may affect the value of y, it means I know the factors or variables and I'm not including in my study. If I say there may be, it means I do not know what are those factors. If I know, then there are other factors that I am not including in my study because of certain reasons, maybe of control variable or whatever. But there may be, it means I am not aware about the factors which may explain the variance in my this dependent variable. Okay, clear? Any question, Santa madam? Sapna
yes.
madam, any question? Anybody else also? No. Okay, so in this course, we shall concentrate on stochastic model because studies are based on stochastic model. Stochastic model alpha plus beta x plus error term. Solving such model will mean finding the values of estimators of the parameter alpha and beta. So in this model, the values of x will be given based on the parameters alpha and beta. We will calculate the value of y. Am I right or wrong? Independent variable x, it will the value of x will be available. We will calculate the values of parameters a plus a and b, and based on these, I will calculate the value of y. So I need to calculate the value of parameters alpha and beta. So let's spare some time for the basics before we proceed further. What are those basics? Regression versus causation. Can anybody tell me regression and causation are the same thing or are they different? Yes, please. It's always good to interact. Regression versus causation. Regression deals with the dependence of one variable to the other. It does not mean causation. Regression provides only statistical relationship. So a statistical relationship, however strong or however suggested, can never establish causal connection. Our ideas of causation must come from the statistics, ultimately from some theory or other. Let me ask you one question. Sensex prices are dependent on the prices of Reliance Industry, or Reliance Industries prices are dependent on Sensex. Are you getting my point? Hello. The share prices of Reliance Industries are dependent on Sensex, or Sensex is dependent on Reliance Industries share price. Can you tell me? No one?
So I think the share prices of the Reliance Industries are dependent on the Sensex.
But other way you think that how the value of Sensex is formed?
Yeah, it is an index.
Share market. There are so many other companies and so many
No,
other
no.
factors.
On the basis of 30 companies, the value of Sensex, whatever is the value of Sensex, is on the value basis of 30, the share price of 30 companies, which denotes Sensex.
Yeah.
So which one depends
Yeah.
on what? Okay, please.
So it is not only the Reliance.
Okay, but one of
There are
the
a group of 30
one of the
companies.
factor may be Reliance. One of the factor may be Reliance out of 30. Out of 30, one factor is Reliance. Price of Reliance. Some background noises are coming. So regression will never tell me a position which one is dependent and which one is independent. Regression will not tell. I have to tell to the regression analysis which one is dependent and which one is independent. Regression will not tell which one is dependent and which one is independent. If you take Reliance Industries as independent, Sensex as dependent, there must be some relation, maybe some regression value. You reverse the equation, you may also find some regression values. So you have to find it out from the literature, you have to find it out from the review, which one is dependent and which one is independent variable. So regression never tells you the cause and effect. You have to find from review of literature. Now regression and correlation, what is the relationship between them? Please appreciate. All the terms are known to you. Tell me, what is the meaning of regression and correlation? Is, is there any relation? Okay, tell me. Without correlation, is regression possible? Strength and association can be tested with the help of, sir, with the help of regression or correlation. With the help of correlation, yes, please, sometime, please.
With the help of correlation,
With
we
the help,
can,
very good.
yeah.
With the help of correlation, we can find out the relation, the strength of relation between two and more variables. So without correlation, regression is not possible. Regression tells us the dependence of one variable on another variable, and correlation tells us the strength of the relationship between or among the variables. Okay, so if there is no correlation, zero correlation between dependent and independent variable, then there is no regression also. If you remember, in exploratory factor analysis, we have created factors which are totally uncorrelated. If we run the regression on those factor scores, then we will not find any kind of regression. We will not find because they were totally uncorrelated. So if there is a correlation, then only the possibility of regression is there. But which will be dependent and which will be independent? This is the case of causation, and we have to find it out from literature. So is it clear? So correlation analysis provides the strength, degree, and nature of linear association between two variables, while regression analysis provides the dependence of one variable on other variable or variables. Correlation analysis is symmetrical. while regression analysis is not. Correlation analysis assumes that both the variables are random, while regression analysis assumes that the dependent variable is stochastic, but independent variable may be fixed or non-stochastic. Okay, so independent variable may be non-stochastic, but dependent variable is stochastic. Now, let's start with regression model. First, we will discuss about classical regression model. So, what is classical regression model? The general form of classical regression model is y is equal to alpha plus beta x plus error term I1 to up to n, where the above equation is called simple linear regression model. It is also known as two variable linear regression model. If we increase number of independent variables, then it will become multiple regression. Alpha is called intercept parameter. Beta is called slope parameter in random in relationship between variable x and y. Error term is called as error term or disturbance term or noise term. Actually, when we read the papers, we will find it out the different terms: error term, disturbance term, noise term. So all of them are the same thing. Don't bother about this error term, disturbance term, or noise term. Now, you must understand the basic terminology for simple regression model. Y is the dependent variable, X is independent variable. But at the time of reading paper, you must be getting some fancy names like dependent, independent, explained variable, explanatory variable, response variable, control variable, predicted variable, predictor variable, regression variable, regressor variable, endogenous, exogenous. So all of them are dependent, all of them are independent variables. The other names for dependent and independent variables. Clear? Any doubt? Okay. Now,
Hmm.
yes, Sapna madam. Do you have any doubt?
No, no, no. No.
Okay. Now, every classical linear regression model is stochastic in nature due to the error term, as the behavior of error term is random in nature. So error term takes care of other things being constant or ceteris paribus, means other things remain same. Other things remain constant. We take it as assumption that if other things remain same, then this will be the equation for us. So why are the models not error free? We must think why the models are not error free. Why error is there? So why disturbance error term? The disturbance or error term in a stochastic model is used to capture explicitly the size of error, message, or shocks that cannot be explained by the explanatory variable. So whatever is left from the explanatory variable, independent variable, that goes to error. Whatever we missed during the estimation, that goes to error. Any shock in in stock market data, if you see, there may be sudden shock. The prices of any share may suddenly go up or may suddenly go down. That may be uh, treated as shock. So that shock is also goes to error term. Usually following rationals are given for why error term. Error term, the rationale for error term. First one is omission of variable and specification error. If we have omitted certain variable, we have not taken variables in our model. Whatever variables we have taken in our model are known as variables of interest, And by mistake, if we have omit some variable which must have been taken in our model, the effect of those variables goes to error term. And if we have any specification problem also, then this will go to error term. Non-linearity in relation. We are talking about a linear regression, but if there is a non-linearity of relation, then it can go to the error term. Measurement error, if we have some kind of measurement error. Human, okay, indeterminacy or stochastic nature of economic and financial process, this will also go to the error term. So that's why we put error term in our equation. So classical linear regression model, what are the assumptions? Basic assumptions, zero mean of the disturbance. Please listen carefully. This assumption or maximum assumptions are related to error term. What is the assumption? Zero mean of disturbance. Error term must have zero mean. Means normal distribution. It must be normally distributed. What? Error term must be normally distributed. Homoscedasticity. It means the variance is equal to standard deviation. Means constant variance must be constant for all error terms. So there is a condition for heteroscedasticity for independent variables, but for error term, they must be homoscedastic. The variance between constant variance between error term must be constant. Non-autocorrelation. Okay, can anybody tell me what is the meaning of autocorrelation? We have time means only today's time. Otherwise, autocorrelation is a separate chapter. And do you know the meaning of autocorrelation? Anybody? No?
No,
Yes,
sir.
please. No. Okay. When we talk about the prices of share, can we say that today's price is dependent on yesterday's price and tomorrow's price will be dependent on today's price? Can we say?
Yes, it is influenced.
Maybe or may not be. When DD and
Yes.
ID are automatically told, no, no, no. This is not the meaning, sir. Sir. Autocorrelation means we are talking about time series. Okay. So today's value is derived from yesterday's value, and tomorrow's value will be derived from today's value. Then there is a autocorrelation. Auto means from the previous observation, it has some correlation. Then it is known as autocorrelation. Okay. Auto means in itself it has a correlation, means from previous observation it is correlated, and next observation will be correlated from this observation. So for error term, we say that there should be no autocorrelation, means non-autocorrelation. Covariance must be zero. Uncorrelatedness of regressor and disturbances. Here we are talking about the covariance of independent term and error term. So independent variables and the error term must be uncorrelated. Here there should be no correlation between or among the independent variables and our error term. If there is a correlation, then it can create a problem. Okay. Normality of error term, we have already discussed in first point. Non-stochastic regressor. The value of x is a known constant in the probability distribution of y. It means the value of x must be non-stochastic. If it is stochastic in itself, then it has some more predictors, so then there will be a problem. So value of x must be known. So whenever we solve the problem, we always know the value of independent variable and parameters alpha and beta. Based on those, we calculate the value of dependent variable y. Am I clear? If you don't know the value of x also, how can you calculate the value of y? Okay, any question till now?
Sir, here, sir, in non-auto correlation, we are talking about which two things, like error and independent, or error and dependent?
No, we are talking about the values of error term must not be correlated with its previous value. Let me take an example. The share price of today, if it is dependent on yesterday's price and tomorrow's price will be dependent on today's price, then it is autocorrelated. It has autocorrelation problem. So I can predict on the basis of tomorrow's price, today's price. On the basis of today's price, I can predict tomorrow's price if I find the relationship and the prices of previous day and previous day and previous day and previous day. Are you getting my point? Autocorrelation means the correlation of its lag. Lag means previous day's price, previous day's value, previous observation. Suppose you measure the rainfall every day and you find some correlation between the rain of day 1 and day 2 and correlation between day 2 to day 3, day 3 to day 4, day 4 to day 5, like that. If you find such kind of relation, then you can predict the rain for the 11th day on the basis of this correlation. Yes or no?
Yes.
So this relationship is known as autocorrelation. Maybe temperature, but if it has some correlation, then only we will say that it has autocorrelation. If it does not have any correlation, then we will say it does not have any correlation. So in our case, error term must be free from autocorrelation. It must not have autocorrelation. Okay. When we talk about uncorrelatedness of regressor and disturbances, here we are talking about the correlation between the independent variable and error term.
Independent.
Here we are talking
Yes.
about. But auto correlation means the correlation within the series, within the variable, not between.
Okay.
Okay. Any other question? Okay, let's move. So basic structure of assumptions. The model is complete, model is linear, or model is additive. Do you know the meaning of additive? I want to go to, let me see. Okay, just, can anybody tell me the meaning of additive? If you know, no. Let me tell you what is the meaning of additive. So insert. Okay, suppose this is my independent variable y. So the area under the circle is the variance of y. What I do, I run a regression and I introduce a variable known as independent variable and this independent variable, just a minute. Oh, okay, चलो. Um, not there. So I have one mm, dependent variable that is y. I introduced one variable that is x. So the portion, this portion, or better, I should go to paint. Just wait. That will be easy for me. Yeah. I'm sharing my complete screen. So this window of paint is visible to you. This window of paint is visible to you.
Yes.
Okay. So what will I do here? I will draw some. Okay. So this is my variable x, sorry, y, dependent variable. I run regression and introduced one variable x. So this is the portion which has been explained by um, x, the variance explained by x in y. Clear? Any doubt? Hello? Is it clear or any doubt?
Sir, please explain again.
Okay, should I explain again? Just so this is the variable y, means dependent variable. I want to run regression. I introduced one variable that is known as x. This is x. I have introduced. This portion, if I draw lines here, this portion of variance of y is explained by x. Am I right or wrong? This portion of, are you getting
Yes,
this
sir.
point or not? So
Yes, sir.
this portion has been explained by my independent variable x. What if I introduce another variable, and that is known as x2, or I say y, means this one was y, and this is x1. This is x2. Okay, this is dependent variable. This is IDV. One, and this is IDV2. Okay, so if I introduced IDV2, what happened here? What happened here? This IDV2 means x2 is explaining this part of y. Yes or no? This part of y. Yes or no?
Yes.
And there is a certain
Yes.
common area. This is the common area which is x, which has been explained by x1 and also by x2. This blue colored area is common area which has been explained by x1 and x2. So by introduction of x2, the addition is only this one. the area which I am drawing in green. So this is the addition only. If I do not introduce x2, this area will not be explained. So because of x2, this is the additional area. So if adding any independent variable improves my R square, then I will say that model is additive model. Sometimes it happens adding one more variable may reduce R square. So I will say this variable is not contributing to my model. Either it is coming down, R square is coming down, or R square is not improving. So I will say this variable is not contributing my dependent variable. So not contributing in my model. So I will not use that independent variable. So whatever is not explained, this is error term. Whatever has not been explained is error term. And this portion has been explained, and this portion has been explained by x1, and this portion has been added by x2. So my model must be additive model. If I introduce independent variable, R square must improve. If R square is not improving, then I can say that variable is not contributing to the model. Is it clear or any doubt? You can ask as many questions as you wish. Hello, done? Okay. So let's move ahead. Now the challenge is to how to estimate the best way appropriate values of alpha and beta. So before that, we have to understand population regression function and sample regression function, though we have discussed. What makes the difference between the population regression function or sample regression function is the presence of error term in a regression model due to sample data. Why do we put this error term in our equation? Because of the sample data. Because we are taking sample, we are not taking the population data. So we can say that population regression function does not have any error term, while sample regression function has error term. So deterministic model means population regression function, while stochastic model means we are working on sample data. So can you see this? This is the population regression function. We have taken all the variables, and x-axis denotes debt equity ratio and y-axis denotes EPS. So this is the relationship between EPS and debt equity ratio. So here the value is EPS is dependent on debt equity ratio. So we have taken all the values here and we have drawn a line. This is population regression function, and we can see there is no chance of error because all the values has been covered, and this regression line is in the between of every observation. So half of the values are above and half of the values are less. So if I extend this line, I can predict for future exactly what will be the next value, next mean value. So we always work on mean. So what will be the next mean value? We can predict for this on the basis of population regression function. Any question? Any doubt? No? Okay. Let me move ahead. So population regression function we have discussed. Population regression function or population regression line is the line that is derived on the following equation. So expected value of y by x is equal to alpha plus beta x. Geometrically, a population regression line is simply locus of conditional mean or exceptions of the dependent variable for the fixed values of explanatory variable. It tells how the average response of y varies with x. You can see the average. It is working on the average. How the average of y is based on the values of x. So graphically, we can present this is the normal distribution of every observation, and we have taken the mean and we have jointed the mean of every observation. So in future, we can predict what will be the mean value of next y on the basis of x. So do you think that it is possible for us to determine population regression function? So some may say yes, some may say no. It is possible, but not so easy. That's why we work on sample data. Whenever we work on sample data, what we do, true relation between y and x, and thereby the true values of parameter alpha and beta is given by the population regression function. So we calculate like that. The above relation is estimated using population, but in real life, we have to estimate using the sample data. Okay. Therefore, we have to estimate population regression function using sample data, and it gives the following sample equation. Here you can say the alpha hat, beta hat, and the error term hat. Can you tell me what is the meaning of this hat? When we put this hat, what does it mean? Anybody? Okay. So estimated value. Now we will talk about estimated values of parameters alpha and beta and error term, because value of y will be given, sorry, value of x will be given, and on the basis of value of x, estimated value of alpha and beta, we will calculate the value of y. So coming back to our challenge to estimate parameters, so methods of estimation, broadly two methods are available: ordinary least square and maximum likelihood estimation. This is MLM or MLA. So yesterday, when we were working on AMOS, we were working on MLE method, maximum likelihood estimation method. Here we will work on ordinary least square method. So how to obtain the line that is best fit? You can see this line is best fit. Okay, how can we say that line is best fit? Can anybody tell me how can we say that line is best fit? If we draw this regression line that is best fit, how can we say? Statistically, we have to see the minimize the sum of difference between actual and fitted value. The minimization, the difference, you can see this is the regression line, and this is the difference between mean line, means fitted value, and this is actual value. So this difference, this difference, this difference, likewise all the differences, and we will take the sum of all the differences. That should be minimum. Minimize the sum of squares of difference between actual and fitted value. Another method is we will take the square of these differences and we will sum that, and that should also be minimum. So in regression equation, we have sum squared of mean, and we have mean squares also, and we have the sum of differences also. So these are the error terms, and this must be minimum. So these are the estimation by least square. These are the sum of squares of estimation, and least square method minimizes SSC, sum squared of estimation, with respect to beta 0 and beta 1. Beta 0 means the intercept, the alpha, and this is slope. In estimation, this has been minimized. So how we calculate estimations? Least square regression estimators. Slope, we calculate slope like that. Intercept we all have calculated in regression function. So sum of squares and cross product, but software will do us for us. We need not to calculate manually. We must understand this. The parameters of classical regression model determined by least square method. Using the least square method, the estimate of beta is determined. The slope, the formula to determine slope, is the summation of x minus x bar, y minus y bar, and summation of x minus x bar square. And estimate of alpha can be determined like that: y minus y bar minus dy x, v x bar. So again, to the history, knowing history of ordinary least square method. The method of ordinary least square is attributed to German mathematician Carl uh, Friedrich Gauss. Under certain assumptions, it has some very attractive statistical properties, making it most attractive and powerful method of regression analysis. What are those assumptions? Since alpha and beta estimates are estimated using sample, they have their own statistical properties and behavior. Can we guess how they behave statistically? Let us see. So these are the estimators of alpha and beta. Then these estimators follow normal probability distribution. So how we calculate, again, variance of uh, alpha and variance of predicted alpha and like that beta and estimated beta. Now come to these are very important things, properties of OLS estimates. Gauss-Markov theorem. This theorem says that given the assumptions of classical regression, the OLS estimators in the class of unbiased linear estimator have minimum variance. They must be blue. It does not mean they must be blue in color. Okay, blue does not denote color, but blue has some meaning. Blue, B means best. Best means minimum variance. There must be minimum variance. L means linear, linear function of variable. U means unbiased. Their expectations are equal to population parameters. Means there must be least difference between the expected and actual data. Estimators, the estimate from sample information. So we must estimate from the sample population and sample information, and it must be generalized for the population as well. So any question out of them? Blue. Okay. So OLS estimators are best because they are linear, unbiased, efficient, consistent, and sufficient. So they must be linear, they must be unbiased, efficient to explain the variance, consistent. So we can say this, if this will be the value of x, this will be the value of y. Sufficient, they must have sufficient R square. What are the statistical properties of our estimated y in the model? So y, expected y means estimated y. What are the properties of dependent variable? Dependent means estimated. Statistical distribution of y. Since error term follows normal distribution, yi means estimated y also follow normal probability distribution. It means its mean and variance will be given by estimated y is equal to estimated alpha plus beta, estimated beta, and the mean value of x, or this is the value of mean, and this is variance. Variance in y is explained by expected value of yi means y mean square. So now let's see statistical properties of error term in a regression model. So once again, error term must be normally distributed, as we have already discussed. Its mean and variance will be given by error term mean must be 0. Variance, and this is unexplained variance. So unbiased estimators means the estimators square minus is equal to means the sum of squared is must be equal to estimated sum of square. So this is the formula to calculate. Now we have to understand the estimation procedure, properties of our estimate of regression model. What are those? So applying our learning. So mastering Excel for regression, because how many of you have eView software? How many of you have anybody who has eViews? Anybody? No. Okay. So I should go for Excel. I thought that you do not have eViews, so I should go to Excel once again. So we have three methods. There are three ways to estimate the parameters of regression. We have three methods. One using chart utility with trend line. Second is using inbuilt function. Third is using regression of data analysis. In Excel, we have earlier we have done regression, but today also we will do with three methods. Earlier we have done with one method. Now we will do with three methods. So likewise we will do. So you must have one file. mm, I think one file. I have shared you one file today.
RIL.
Yes, RIL returns. Open that file. Open that file. Excel everyone has, so I choose Excel for the purpose. Okay, is my file visible to you? Okay, so we have three methods to estimate our um, parameters. So one is inbuilt function. What is inbuilt function? So I am writing inbuilt function is equal to linest. This is inbuilt function linest. Then known by. So if I have BSC returns and RIL returns, which one will be Y and which one will be X? This will be based on our literature. I can take anybody as X, anybody as Y. But generally, I take RIL return as my Y means dependent variable. I have selected them. Then I will put comma. I will take known X. Okay. Then double comma, and I will write true, close, and I will enter, uh, not only enter, but shift control plus enter. So it will, because this is an array function, so this will give me the 10 values. This will give me the 10 values. What are those values? I will let you know. And because I have selected extra columns, so it has given NA, but this will give only 10 values. So are you able to calculate? Are you able to calculate? Yes or no? No? Okay. I will select all the values. Second method, graphical method. I will select all the values. I will insert, go to scatter diagram. This is a scatter diagram. Okay. I will I will right click here. What? Okay. After clicking right on this area, I have one option, add trend line. So this pop-up will be there. I want linear relation, and I want to display the equation and R square. So close. This will tell me the equation and R square. If you compare this with the previous value, you will find the same values. Okay. So this is my equation. So y is equal to, this is intercept intercept. I have, this is, you know, 0.1873. This is slow. No, this is beta because this is with x. So this is slow. This is point. This is R square. 0.16. This is your beta intercept. Other values you will compare with the regression method. You will run regression equation and you will find the values. So I'm running the third method, that is regression. Go to data analysis, regression. Okay. So what is my y? Y is dependent variable. What is my x? X is my independent variable. Confidence level in first line, confidence level 95%. Output range, I want my results uh, here. So I will compare. Okay. So these are my results of regression, and I will compare all three. I will compare all three. So let's compare the results. So I have received R square 0.018729, 0.0187 R square, and in this case also R square 0.0187. What is the intercept value? Intercept 0.1604.1605 round off, and in this case also 0.016465. So same values I have received. I have received mm, the values of standard error also 0.187 this value. So I can calculate this is standard error. This is my degree of freedom 246 residuals. This is my residual sum of squared. This is my explained variance. So likewise, I have calculated this is f square. So I have calculated my values in this way. So I have three methods to calculate. Any question in this? Any question? This I am working on my time series data. Okay. So you can see this is the regression line. The values which are away from regression line, they will create the problem. You can see the values away from the regression line, they can create the problem. These values, variance will be high, error term will be high. Okay. Any question till now? Any question till now? So I have calculated this linear function. Inverse function was slope. We can calculate with the help of slope also. Intercept we can also calculate separately. Correlation we also calculated. R square also we can calculate it. R square. But for all the values, I have one inverse function that is known as lineage function. So I can calculate the lineage function like it. So it is array function. So it will work by control shift and enter simultaneously. It gives me the summary coefficient of x, standard error of beta, r square f value, standard sum of square regression, intercept, standard error of intercept, standard error of regression, degrees of freedom, and sum square of residuals. It will give me the values like that. 10 values it will give. So I can use this function also. I have used regression function. Now the challenge one is it true that companies with high risk have low PE ratio? If you can imagine, please imagine and tell me. Is it true that companies with high risk has lower PE ratio? PE means the price earning ratio. It is a problem of estimation, testing, or hypothesis testing. Tell me, what is the kind of problem? So it is a problem of testing hypothesis. I want to check whether the company is having high risk has lower P ratio or not. So hypothesis testing simply. So what should be the testable model? PE is equal to alpha plus beta plus error term. This you can see beta. What does it mean? This beta is parameter, and this beta is the measure of risk of the company. How to estimate the value of beta of company? Now again, it is a problem. So it is a problem of estimation, testing of hypothesis. It is a problem of estimation. We can calculate the beta by estimating. So challenge number 2, what should be the testable model? So return is equal to alpha plus beta, market return plus error. So return of security is equal to alpha plus beta and market return, then error. Can we test whether there is any relationship between dividend payout and net cash flow from operating activities? Is this problem of estimation, testing, hypothesis testing, or forecasting? So it is a problem of estimation. So we want to estimate. Okay. What should be the testable model? Dividend payout ratio is equal to alpha plus beta net cash flow from operations, operating activities plus error. Like. Now we proceed further. Try to what next? How to know that whether model we have designed is a good model or not? Let us understand. Is the model a best fit overall model or individually? We want to see it. So evaluating the goodness of fit of regression, how well the model fit is in overall. So one of the ways in which fit of regression can be evaluated, whether variation in X is a good predictor of Y or not. Are you getting my point? So what is your R square? So variation in X is a good predictor of variation in Y. Is X able to explain the variance in Y? To understand this, we must use R square, coefficient of determination. It is a measure that represents the proportion of total variance or variation independent variable explained by the model. So we must see the R square. If my R square is good enough, then I can say that my model is fit. And if you remember in SPSS, when we run regression, there is one table called ANOVA, and it gives us the p-value. If my p-value is less than 0.05, I can say that my model is fit. So it denotes that my R is not equal to 0, R is away from 0. But in case of other softwares, even in SPSS, oh, sorry, in Excel also, we do not have this uh, parameter. So we have to check our own whether my R square is sufficient or not. Higher the value of R square, higher the variation explained, and hence it is better fit. So higher the value of R, better it is. But how much higher? Suppose if I get the value of R 1, so will I say my model is fit? No. I have to see whether it is because of homoscedasticity. Um, so I have to check for this also. So sometimes spurious regression also gives a higher R, so I have to be aware about that. So this is the model summary. This model summary from SPSS itself. So summary output model is like we will see R square. This is 0.1169, means almost 11%. I will see the significance value F. I can say that my model is fit. Um, So goodness of fit, how well model is fit in overall. Again, I will see what I will see. Second way is to in which the overall fitness of a regression model can be evaluated. Standard error of regression SER. It is defined by this model, this formula. So SER is equal to RMSE, root mean square error, and hence lowest it is, the better the model is. But how will I come to know that this is lower or not? So I will compare models, model 1, model 2, model 3. I will see, I will choose the model which has higher R square and lowest this SER. So in this model, standard error, this is 1.12. So I cannot comment until I have another model whether this uh, standard error is less or not. So I need to compare with models. So again, goodness of fit, how well the model is. Again, another way is ANOVA. So ANOVA helps us determining whether model, uh, whether variance explained one due to regression is statistically and significantly different from variation that is due to error term. For this, we use F test. So if the value of F is significantly different from critical value, then it means that variation explained by the model is significantly different from error term, and therefore model is fit. So I see my value of ANOVA. So analysis of variance, ANOVA table, source of variation. This is regression, this is residual, this is total. So degrees of freedom, like that, mean square. This is sum square of regression divided by k. K means degree of freedom, and this value of is divided by this value. So F statistics is the ratio of mean square. This divided by this. So we will get this. So in ANOVA, we see the significance level. If my significance value is less than 0.05, then I can say that my model is fit. So now we will see the goodness of fit on individual basis. We can evaluate the model on the individual basis. That is, for each component in the model, we can test a particular hypothesis, and this testing will help us determining to what extent the model is fit or not. So we make null hypothesis for intercept term and for the slope of the independent variable, and then we perform hypothesis testing. Usually, statistical packages that are available make null hypothesis testing um, for itself, and it will tell whether slope is 0 or not. So how we can see, we can go this. So coefficients of intercept and beta slope, we can see the p-value. Software gives us this for us, hypothesis testing. If p-value is less than 0.05, we can say that these values are significant. It means these are not equal to 0, these are away from 0. If we have these values of p more than 5%, then we can say these values are not significant, though they may not be 0, but they are not significant. So chair test and t-test we have. So what next? So testing time. Uh, as I told you, intercept term. This is intercept term, and this is beta. So how do we estimation? Estimating determinants of bonds credit rating of company. These are the problems of estimation. Estimating factors. Sorry. So I was discussing about problems for estimation, problems for forecasting and hypothesis testing. So these are some problems of estimation. Estimating determinants of bonds credit rating of a company, estimating factors that determine capital structure of the company, estimating relationship between share price as dependent variable and EPS, DPS, dividend payout ratio, size, variability in earning, growth in sales as independent variable, estimating the relationship between spot rate and forward rates of the currency. Then problems of hypothesis testing, testing whether CAPM works in India, testing whether Indian stock market are weakly efficient, testing whether earning or dividend announcement has no impact of a company's share return, testing whether the spot market or future market react more rapidly to news, testing whether a person can make abnormal return using some technical trading strategy in the Indian stock market. These are the problems of forecasting, forecasting the degree of correlation between the stock indices of two countries, forecasting volatility in the stock market, forecasting interest rate in the market and associated volatility, forecasting share return in the Indian stock market, forecasting reversal in trend in share price, forecasting forward rates based on spot rate. So now I want everyone to switch on their cameras and we can interact for 5 minutes. I would like to stop here for my sessions, but I want to interact you for 5 minutes. If we can we have interaction for 5 minutes? so that we can understand. So on day one, we interacted for 5 minutes. Now can we, and what else you need in future? Means, I want to know your experiences during this FDP. Saurabh sir had shared one feedback form also, but interaction, uh, uh, or Saurabh sir, may I request you to stop recording so that they can finish.
Okay, okay, sir. Okay, sir. We are stopping recording, and
They can,
I must share my feedback. It was an excellent session, and thank you for sparing so much time. 2 hours to lecture as a faculty, it's a huge task after a whole full work day. So I must compliment you on the great work you have done and championed the cause of research. So I am just stopping the.
thank you so much, Saurabh sir, for providing me the opportunity uh, to deliver this FDP. So after recording